Right, guys, this is for those of you who missed class today or need to review. This is section 2.7, factoring special products. Use algebra tiles to write each polynomial as the product of two binomials. State whether the product is a special product that you studied in section 2.3. 2.3, I think, is page 45. So let's see here. We have 4x squared, which is 2x. And then we have 2x times 2x makes 4x squared. 2x times negative 1 makes negative 2x, and 2x times positive 1 makes 2x, and then positive 1 times negative 1 is negative 1. So we have 2x minus 1 and 2x plus 1. And it asks, state whether the product is a special product that you studied in section 2.3. What were those special products anyways? They were a plus b squared, a minus b squared, and then, let's see, why can't I insert text? Just be another, let's see, this be in black or something. Yeah. So they were a plus b squared equals, oh no, why? All right, well, it was a plus b squared, a minus b squared, a minus b squared, and then a plus b times a minus b. If you don't remember what those are, then go on back to section 2.3 or page 45, and they are on there. In any case, this is one of them. So yes, this is a special product pattern. Next, we have 2x times 2x to make 4x squared. And then we have a negative 1 and a negative 1. Why? Negative 1 times 2x is negative 2x. Negative 1 times 2x is negative 2x. And lastly, negative 1 times negative 1 is positive 1. So this is 2x minus 1 squared, which is a minus b squared. So yes, this is also a special product pattern. Moving down, how can I do that? Moving down, let's erase everything. We have this one, which ends up being 2x plus 1, and the same on the left. So this is 2x plus 1 squared. And lastly, we have 2x. What do I multiply 2x by to get negative 2x? That's a negative 1. And what do I multiply 2x by to get negative 4x? That would be negative 2. This is not a special product pattern. It's not. But here's the factor form of it. 2x minus 1, 2x minus 2. That's all it is. Moving on to the next section. Use algebra tiles to complete the rectangular arrays in 3 different ways, so that each way represents a different special product. Write each special product in standard form and in factored form. So we have 3x and 3x, and we have a couple options here. We could do, since there are 6 here, it's going to be 2. And it's up to us whether we want it to be positive 2 or negative 2. I will just go with positive 2. So all these in here are positives. And you fill that in through these 6. This also is a positive 2 because positive 2 times positive 3x makes 6x. And so on. And 2 times 2 is positive 4, so all these would be positive as well. But it asks us to write each product in special product in standard form and in factored form. So the factored form would look like this. And these are all positive, so it would be 6x here and positive 6x here. And this would be positive 4. So I have 6x, 6x. This is the factored form. And now for the standard form, that is 9x squared. I have 6x plus 6x, that makes 12x, plus 4. So here I just chose to do the two positives. Here you could do 3x minus 2, 3x minus 2. And then here you could do 3x plus 2 and 3x minus 2. And to see what you get in factored form and standard form, it's really important for you to do that. So you guys notice like the different pattern, which I will type out right now. So I think I just have to change the color a little bit before I can type. So the other ones are 3x minus 2 squared. Don't do that. 3x minus 2 squared. This caret just indicates, an exponent. So that ends up being, if you work it out on your own, it ends up being 9x squared minus 12x. Why does it do that? Minus 12x y plus 4. And then the other one is 3x plus 2 times 3x minus 2, which equals, what does it equal? 9x squared plus 6x minus 6x, which is 0, minus 4. So those are the special product patterns. And so last week we went from multiplying, which is going from factored form to standard form. And today, or in this lesson, we are factoring, which is going from standard form to factored form. So we could just jump in. This page right here is to kind of like show you, okay, well, if you have one square minus another square, that just turns into the first thing squared minus the second thing squared. And when you rewrite it in factored form, that's what it looks like. These other trinomial, or when you have three terms in a polynomial, so if it has three terms, then you could basically, it's going to be an a plus b squared or an a minus b squared. And then again, just following this pattern, if everything is a plus, then you know that it will be like that. If you have a minus in there, and you will also have minus in the factored form. One thing I will say is that the third term, the constant, does not matter because a positive times a positive will be positive, and a negative times a negative will also be positive. So make sure you look at this as you're working through, and it could give you a lot of help. So 1 through 12 is all, look, it's two terms. It's just two terms, right? And it's subtraction. So if you go back to page 65, like which one is, which one of these shows two terms only with subtraction? Okay, well, here it is. So that means you're going to have to take the square root of the first term and the square root of the second term. So what is the square root of s squared? Sorry, the square root of s squared is s, and the square root of 49 is 7. So it's just square root first term, square root last term. Here, if the square root of s squared is 7, I know this is going to trip you guys up. You guys think it's a really big number. But the point of these product patterns is that you don't have to do something. You can do mental math if you break down the pattern first. So again, this is just like this. And what that will end up being is the square root of 57 squared is 57. And the square root of 53 squared is just 53. And so it is fair for me to factor it as such. And you don't have to think about foiling or anything. What is 57 minus 53? 4. And 57 plus 53, to break it down for you mentally, 50 plus 50 is 100. And 7 plus 3 is 10. So that makes 110. And then if you multiply 4 times 100, you get 400. And 4 times 10 is 40. So you'd say 400 plus 40 is 440. Again, the point of this is that you do it with no calculator, and you're able to do it all. Okay. Moving on to this one. Now you have three terms, so you have to go back a little bit more, and you're basically trying to figure out, okay, well, if it has three terms, which one of these patterns are going to fit. So we have x squared plus, this is number 13 by the way. We have x squared plus 16x plus 64. So if this is x squared plus 16x plus 64, you would basically just say, okay, well, what's the first term? What's the square root of x squared? X. And what's the square root of 64? 8. And that's basically it. So that'll be number 13. And number 13 through 18 are all like that. Number 19 through 24, it involves you, it says to solve. So first I would rewrite using the patterns. And in this case, it's just two terms. Then I know I just have to take the square root of first, square root of the second, or square root of the last term. And if two things multiplied together equal 0, what do you know about one of them? One of them equals 0. So you would set this up, x plus 12 equals 0, solve it. X minus 12 equals 0, solve that. This one does not equal 0 yet, so I have to subtract 49. And after I subtract 49 from both sides, I would get something like this, 9y squared minus 49 equals 0. And again, this is just two terms. So you would say something like the square root of 9y squared is 3y, and the square root of 49 is 7. And again, you would say 3y plus 7 equals 0, 3y minus 7 equals 0, and then you solve. You add 7 or you subtract 7 and you divide by 3. For 23, you have to add 1/9. For 24, after you add k squared, should look like this, k squared minus 6/5 k plus 9 over 25. But again, if you pay careful attention to the product patterns on page 65, you pretty much are just dealing in the square roots of the first term and the last term. So this is k, and this would be 3 over 5. You look at, analyze this carefully using the product patterns to figure out, what you would do with that k and 3 over 5. Here you would add 1/9, so n squared plus 2/3 n plus 1/9. Again, just make sure you make careful use of the formulas on page 65 and the patterns to notice, like, oh, what would I get when you take the square root? All right, that's it for this lesson. Your homework is to do everything else on these 2 pages, so good luck.